Hi, it's Tom. In this video, we're going to talk about random numbers in C++. We'll start off with an activity where we're exploring the rand and srand functions. Then we'll go through an activity where we're scaling random numbers. And the final activity will be using a function to generate a random number in a particular range. For the first activity, we'll modify a simple program that illustrates the use of the rand and srand functions. If necessary, pause the video and open up the starter file that you can download from DC Connect. You'll follow along with my explanations and modify your code. Again, feel free to pause the video at any time. Let's look at the starter file and see what it does. First off, you can put your name in the author because you will be writing this and today's date. So in order to use the srand and rand max, which actually is a constant, not a function, we need to include the C standard library. We've used this library in previous activities for different purposes, but specifically we're focusing on these three things. Also, this particular program makes use of the time, ctime functions, as well as the time t data type. So we're including ctime. So we've covered that in a previous program as well. The purpose of this program is to generate a certain quantity of random numbers and display them on the console. So I've started off by declaring an unsigned integer called quantity equal to 10. I'm also displaying the current date and time. So I've created a time t called start time. And again, you may recall from a previous lesson that time t currently is the same as the integer data type. I'm starting off by setting that start time to time null, which is a call to this time function, not passing it a time t. Basically what that does is it sets start time to the number of seconds since midnight, January 1st, 1970. Okay, so we're going to use that a little bit later on. I also have a variable called random value, which will actually be used to hold a random value in a loop. Okay, so I start off with a little bit of a header. I'm using the ctime function and passing it the address of my start time. It'll convert that number of seconds into a string which shows the current date and time. In C standard library is a constant called rand max. This is set to the largest random number that the rand function will actually generate. And this is usually 32,767. However, that could change. So to make your code more portable, you could actually refer to this constant so that you can anticipate what the largest number might be. I also output how many random numbers I'm actually generating, and I go through a for loop. I start my counter off at 0. While the counter is less than the quantity, I increase the counter by 1. So in the body of the loop, I generate a random number using rand. So that will generate a random number between 0 and rand max. In my case, that's 0 and approximately 32,000. And then I output it. So that loop will loop 10 times, and then I'm done my program. So let's run the program unmodified. So just like we anticipated, we got 10 random numbers between 0 and 32,000-ish. Okay, it appears that that seems to be what we've got. So success. Let's try running it again. So I'll close that and run it one more time. You'll notice the second time I run it, although the time changed, the random numbers that I'm getting are actually the same. It's important to understand that using the rand function doesn't give us truly random numbers. Generating a truly random number is one of the holy grails of computer science. There's lots of really interesting techniques for doing it, but the rand function is not one of those techniques. What we're actually generating is a pseudo-random number, which is a random enough number for certain types of applications. But if you're writing a program for, say, the Ontario Lottery Association or Lottery Corporation, you definitely don't want to be using the rand function to generate the numbers. If you do, let me know. These numbers are in fact predictable. Okay, they're not easy to predict necessarily, but if you know what you're doing, you can in fact predict them. So that's what we mean by pseudo-random. The other issue, of course, is that as I'm running my program, I probably want to get different random numbers every time I run it. So that's the next issue that we'll deal with. To have the program generate a different list of random numbers each time, we're going to use the srand function. So in the source code, right about here underneath your declaration section, we'll call the srand function. It's srand, and I'm just going to pick an arbitrary number, 99. Okay, so this is known as seeding the random number generator. It uses this value to determine where in the list of pseudo-random numbers we want to start. So we'll try running that program. So as we expected, we are getting different random numbers this time. However, watch what happens when we run it once again. We're getting the same random numbers. Okay, so this doesn't really solve our problem. So spend a couple of seconds thinking about how we can actually get this list of numbers to change every time we run the program. In this particular program, we're calling time null and assigning it to start time. That is going to be a different number every time we run the program. So I can actually, instead of using 99, use casting it as an integer, start time. Alternatively, if you didn't happen to have a start time t declared, we could say srand time null. Of course, that would have the same effect. So let's run it now. So we've got a different list of random numbers, okay, than we did in the last run, and I'll run it one more time without making any modifications. And this time we get a different list, so success. So if seeding the random number generator makes our numbers appear more random, then it probably would be even like super random if we were to do it multiple times. So let's try that out. What I'm going to do is I'm not going to be using start time. I'll use the srand time null version here. I'm going to copy that, and I'm going to paste it into my loop. So it's actually going to reseed the random number generator every time we go through the loop. So my theory is that the numbers will appear even more random. I'm not sure how I would tell that, but let's try running that. Now either I'm super lucky and happen to get the same random number each time, or something is amiss. I'll try running it once again. I got a different number this time. It's pretty close, but still, again, the same 10 random numbers. So what's going on? Basically what's happening here is that in my loop, I'm calling the srand function, which is reinitializing it to the current time. But you got to remember, this loop happens very, very quickly. So time null gives me a number of seconds. In the 10 loops happen all within 1 second. So that's the problem there. It doesn't make my numbers any more random to do srand multiple times. So you only need to seed the random number generator one time in your program. So let's consider a few questions. A random function returns a blank value, integer value between 0 and blank. To initialize or seed the pseudo-random number generator or algorithm, we use the blank function. And then finally, true or false. Seeding multiple times makes the values returned by the rand function more random. So pause the video and try to come up with some answers for each of those blanks. Here are my answers. The rand function returns a random integer value between 0 and rand max, which on my computer is 32,767. To initialize or seed the pseudo-random number algorithm, we use the srand function. And true or false, seeding multiple times makes the values returned by rand more random. That is, in fact, false. So in the next activity, what we're going to do is we're going to save a copy of our starter program as CPRG03-08B. Okay, so we preserve the original. We're going to create two named constants, min value, which will be equal to 2, and max value, which will be equal to 12. What we're going to do is we're going to modify the assignment statement in the loop so that the random value is scaled between these two constants that we declared. So what I want is I don't want random numbers between 0 and 32,000. I want random numbers between 2 and 12. So we'll test the program a couple of times to make sure we've done that. So first, I'll save my program, File, Save As, and I'm going to save it as 8B. Okay, and next I create my two named constants, and I'm going to do that up near the top before I declare my variables. And I'm using copy and paste. You're going to actually have to type this in, but pause the video if you need to create an integer constant called min value, which is 2, and max value, which is 12. Now before we get to scaling between these two values, I just want to talk about scaling in general. So in our loop, we have random value equals rand. Now let's say arbitrarily that I want that random number to be between 0 and 9 first off. Oops, that's 7. 0 and 9. Okay, so how can we mathematically change a number that's somewhere between 0 and 32,000 to be 0 through 9? So one trick that we have available to us is to use the integer operator modulus. Okay, so I'll use a percentage sign for modulus, and I will do modulus 10 in this example. So what that does is it divides that integer number by 10 and takes the remainder. The remainder, if you try to divide something by 10, is always going to be between 0 and 9, because you can't have a remainder 10 if you're dividing by 10. So that's a real quick way to scale your numbers if you're starting off at 0. So let's try running that. So we've had some success. In my run here, I've got a 9, I've got a 0, but nothing outside of that range. So that's helpful. So let's deal with 2 to 12 now. If this gives me the random numbers between 0 and 9, and I want to go up to 12, if I were to say do modulus 12, that would give me 0 to 11. And maybe if I sort of want to shift that, I want to say, oh, okay, plus 2, for example. Okay, that gives me a little bit closer. Not quite, but let's try running that. So that basically will give me 0 to 11, and then add 2 to it. So we'll try running. Okay, so we can see this time it almost appears to work. I don't have anything less than 2. I'll try running it one more time. This time I've got a 12 in there. This is why testing is important. One more time. Uh-oh, this time I've got a 13. So what's going on there? Basically what's happening is my rand modulus 12 is giving me 11, and then I'm adding 2 to it, which is getting to 13. So doing modulus 12 is not doing the trick here. How many numbers are there between 2 and 12? So if you count them up, okay, the possible number of answers you could get to that would actually be 11, not 12. Okay, so if I were to say modulus 11 plus 2, okay, this will probably fix my problem. So this time when I run it, it appears to be okay, but to be sure, what I'm going to do is I'm going to change the number of random numbers I'm actually generating. So I'll change the quantity to 100. Okay, that's a better test. So I'll run that again. Now I have more numbers to look at. So I do see I get a 12, another 12. I don't see anything less than 2. I don't see anything greater than 12. So it looks like this is working. So the final step here okay, is that should be 0 to 10 now. The final step now is to use the min and max constants to do this, so that if I want to change what the min and max is, this will actually still work. Okay, so the +2 is plus the minimum. So I'm going to change that from 2 to min value. Now the 11 is the number of answers I could get in between the minimum and maximum value. So I'm going to say, I'm going to take my max value, which is 12. I'm going to subtract my min value, okay, which is 2. So that gives me 10. And then I'm going to add 1 to it. Okay, so that should consistently work. So I'll run that. So this time as I look through the list, I'm anticipating that I won't see any numbers greater than 12 or less than 2. And I think I have some success here. The only little modification I'm going to do here is I'm going to just put the minimum value first. It doesn't really change the answer. But it just looks a little bit clearer to me. So that's basically the expression that I'm going to use to scale my random value between minimum and maximum. So if you need to, pause your video for a few seconds and make sure that your program is actually running with this scaled value. So for the final activity, what we're going to do is we're going to generate random numbers in a particular range, just like we have so far, but we're going to do so in a reusable function. So we're going to save our activity 8b code as CPRG0308C, so we preserve our original, and we're going to create an inline function called scaled random number. The function is going to take 2 arguments, so it'll be 2 parameters, representing the minimum and maximum random number that we want. And then it's going to return the random number in that range. So let's try that out. So first off, I'll save my program as something different here. And then we'll make the modifications. I'll scroll up to the top, and the first thing I'm going to do is prototype the function. So I always start off with my documentation. This is my plan. It's called scaled random number. The first parameter is going to be the minimum random value desired. The second parameter is going to be the maximum random value desired. And what it's going to return is a pseudo-random number in that specified range. So carrying on from there, I'm just going to paste this, but you can type it in. I mentioned that it was an inline function. This is going to be a very short little function, so there's no need to have a full-blown function here. I'll just use inline. It returns an integer, just as I planned. It's called scaled random number. The first parameter is the minimum. I've declared it as a constant, but I guess it could have been just a regular integer. Now I've also got this equals 0 business. This is known as a default argument, which can be very handy. I also have a default argument on the second parameter of maximum, which I've set to rand max, which is at 32,000. Basically what this means is that if the programmer using my function doesn't specify the minimum and maximum, so they just use empty brackets, what they're going to get is a scaled random number between 0 and 32,000, meaning that minimum and maximum will get their values from the default arguments rather than arguments that are specified. Okay, so that's a handy little addition. The body of the function for this is very simple. It's basically just the expression that we came up with before with a return in front of it. So it's going to return minimum, whatever the minimum is, plus a random number between 0 and 32,000 modulus maximum minus minimum plus 1, which is the same thing that we worked out before. So the next thing I'll do is I'll actually call my scaled random number function in my main. So I'll scroll down and I'm going to take this out and I'm going to call scaled rand, random number. If I don't specify, again, if I don't specify any parameters, I'm going to get that very large range. So we'll try running that. So as we expect, those are our very large range of numbers. Now what we'll do is we'll actually scale it using the constants that we declared in main. So I'll go to where I've called scaled random number, and I'll specify minimum value and maximum value. So the minimum value will be copied into minimum, and maximum value will be copied into maximum. So I'll save that and we'll run it again. So we should see now that we get our scaled values as per before. So hopefully you'll find that a useful function to use in the future. So in summary, what we covered in this video was a talk about random numbers in C++. A random number, of course, couldn't be predicted, so really what we're doing with the rand function is a pseudo-random number, because finding truly random numbers is a big deal. Pseudo-random numbers are random enough for the types of applications that we're going to be programming. The two functions that you use most often when you're generating random numbers is rand for the actual generation of the number, and srand, which allows you to get a different list of random numbers each time. Scaling your random numbers is your procedure for adjusting the random numbers that are generated to fall into a specified range. So this is the formula that we came up with. Minimum plus the call to rand modulus maximum minus minimum plus 1. So regardless of the range you're after, this expression should work. Thank you very much.